recording now, folks. So today we're going to use HL. Triangles are congruent. So we're going to begin. Let's write the congruent statement and tell which triangle congruence theorem or postulate justifies it. Okay? So this first one, I want to do this first one together, and then I want you to take some time to work on the others. Okay? And so the first thing I want to point out, Melody, you okay there? Okay. Can you tell me, Melody, how many facts do I have marked in these two triangles? I have 2 already marked, right? But I need a third one, don't I? Harley, do you know what the third one is? It is. Very good. It's vertical angles. And so if I was writing the proof for this, I would say angle what? Can someone name this angle right here? Louder, please. Angle BCA. And so Aaron, since he called this angle BCA, what is the other angle? Angle DCE. That's correct. Notice he went B across the single mark to C and then across the double mark. So she had to do the same thing over here. D across the single mark and then across the double mark. Okay? Now, I've not answered the question yet, have I? Because they want us to write a triangle congruent statement. So what is my triangle congruence then? Emily Peterson, can you help me with this one?
Triangle BCA.
Slow down, let me try. Triangle, sorry, not A. Triangle BCA is congruent to triangle what? DCE. Okay? Now that answers the first part. Now how did I know that was true? Phoenix, can you tell me? Remember the 4? So far we have 4. One of them is SSS. Someone help me. What's the next one? SAS. Someone else. The next one? ASA. Someone else. The last one? AAS. Phoenix, can you tell me which one of those applies here? It's okay if the answer is no. SAS. Awesome. I was going to point out, if you didn't get it yet, I was going to point out how many sides do we have marked. There's 2 there. And so that boils it down to this one, and then just recognize that A is between the 2 sides. So we have SAS. Awesome. Good answer. Okay? Good. Now that's what we're looking for. Now all they're asking for in the answer here in these questions is this. But I want you to go a little bit deeper than that. Point out this. Oh, by the way, why did she say this was true? Vertical angles. So when you point out that third fact, on these next 3, write why. If they're vertical angles, write vertical angles. If it's some other reason, write that. And you just slip it in the middle here, wherever, and then off to the side over here, to the side, write the 2 answers that they're looking for, okay? I'm going to pause this. I'm going to wander around, listen to you, watch you a little bit. Remember, I'm a fly on the wall, so I won't answer your question unless you simply can't read what it's saying. Then I'll help you with those things. And otherwise, I want you to try these. I'm going to scroll down so in the recording they can see what all 3 of them were. So they'll want to pause it and copy them down. And then the 4th one is right here. Of course, you guys have a copy of this, so you don't need me to do that for you. We saw some good things there. We haven't conquered everything yet, but that's okay. We still have time. When did I tell you your test is going to be?
Tuesday.
Tuesday. So we have tomorrow to work on work, to get more help. We have Friday is going to be pull our proof packets out that I gave you, and we're going to finish those up, talk about them together a little bit. And Monday you're going to have a review assignment, which I'll actually give to you Friday. So you'll have it over the weekend if you want to begin it. Okay? And then Tuesday's the test. Remember, there's a group portion and an individual portion. All right. And you don't want to miss the group portion because then you become a group of one. You don't want to be a group of one. All right? So, looking at this, what was the third fact here? Didn't you say you need to go get water?
Yeah, I don't have one.
Oh, sorry, I got distracted. Segment BD, whoops there, is equal to itself, right? So we say segment BD is congruent to segment BD. Why is that? Reflexive. Remember, whenever we say something is equal to itself, the reason that is the reflexive property that we were given a long time ago that said A equals A. Or the one for congruence that says A is congruent to A. Yeah.
You put BB congruent to BB instead of BB.
Yeah. In this case, they go the same direction. Okay? Well, he's right, there is a difference, but in this case, I have it correctly. They go the same direction. Okay? We'll do one in a few minutes, Cody, that switches, and we'll talk about why they switch. So, what is my triangle congruence statement here? Cody, you tell me. What's my triangle over here? How do you name this one?
ABD.
ABD. Is congruent to triangle what, Cody?
CBD.
Yes. Now, that's exactly right. And if you notice, Cody, when you named this, you said A, B, D, C, B, D. So they're in the same order, aren't they? So when they're in the same order, when we're writing them as a statement like that, then up here they would be in the same order also. Okay? Very good. And I'm excited that you're conscious of that and thinking about the order, because everything I've done so far, that's all I really care to accomplish. If you get it wrong, you get it wrong. But if you're aware that there is an order and it does matter, then you will get better at it. Okay? So good job, you've accomplished that. Why is this, Catherine? Why are these congruent? Do you know? What'd you write?
I got it.
Okay, that's what it is. Angle, side. If we go in order, 2 marks, 1 mark, and then the side. 2 marks, 1 mark, and then the side. So it's angle, side. Okay? Good. Now, let's move on to 3. What's the third fact here? EC segment. EC congruent to segment CE. This time we switched them wrong because of why? Right. I combined 2 thoughts together and I confused you. You answered exactly what I said, but what I meant was, why did we say EC is congruent to segment CE? Reflexive property. And sure, her answer, you didn't hear that at home, was because when she writes these triangles, she called it triangle what? ACE is congruent to triangle FEC. And she was saying CE and EC are switched around, so that's why she switched them around. Okay? Good. Autumn, can you tell me why, I didn't mark it, why are these 2 triangles congruent then? Okay, that's a good, fair answer. Let's highlight these. Okay? Highlight those and let's pull them over here then we'll delete them later so we show our work on the next one. So this was EFC, and this one is ECA. And if we go through and mark now what we had this angle congruent to this angle congruent to this angle, and this side congruent to this side. Now if you separate them, Autumn, and we go back to these again, okay? In fact, this is pretty cool. Sorry, I went the wrong way. Okay, now that we can see that on the screen same time, which one of these applies to this? Identify how many angles do we have here? No, how many are marked, I mean? Two, right? And here, Autumn? Two. So we're either looking at, no, that's okay, we don't need that. We're looking at one of those two, right? So the question is, this is to Autumn only, please don't tell her, I want her to think through it. And those who don't get it will be hopefully thinking through it with her. Where is the S located in relation to my two angles? Can you talk without that there?
Between E and C.
Yeah. So we have an angle and the S, and you're saying it's where? In the middle, isn't it? So is that angle side angle or angle angle side? Angle side angle, that's correct. And so that's what we write here. Angle side angle. All right? Now, that was way more confusing looking at it over here, unless your brain is good at separating that. So it might be good for you to redraw them like we did with the red and the blue here. Okay? Come on. All right, now, on this last one here, I didn't leave you a lot of room. Oh, I guess you had a fair amount of room, more room than I did. And I like what Amelia is doing. She's going through and writing these down on every one of them.
That's what I'm doing.
All of these, she's writing them down on every one of these. And what I like it about it, and the reason I like it, isn't that she can't look up the top of the page and refer to it each time, but every time you write it down, it's going to be easier for you to remember. And the more of this stuff you can remember, the easier the test is going to be because you're not going to have to look it up. Okay? When you have to look things up, they take time. And you get confused. The more you know already, the less confusion there will be. So in this picture here, what is our third fact, Megan? Can you tell me? Did you say angle R and something? Angle LCA would be this angle, wouldn't it? And since C is the only point there, and I'm not criticizing you using three letters, that was appropriate. But since C is alone, no other angles there, you can just call it angle C. And you said this? Yeah? Well, since they didn't tell me anything else in the picture, is it okay for me just to say, well, because they look the same, they are? No, it isn't, is it? And here's the tough thing. They are asking us to prove these things are congruent. So that means, to begin with, we know already that they are congruent, don't we? And so when we look at that, we know that angle C is congruent to angle R. But there has to be a reason to support why I know that's true before I prove the triangle is congruent. And in this case, they didn't tell me anything else about it. They didn't tell me these lines are parallel. They didn't tell me these lines are parallel. They didn't tell me any of that other stuff. So I can't say those angles are congruent yet. But there is something else in there that has to be true no matter what. Paul?
Segment LA is congruent to AL, segment AL.
Segment LA is congruent to segment AL. Okay, why is that?
Flexible.
Reflexive property.
And there's 3 dashes in the middle, not 2, because there's already 2 dashes.
Oh, thank you. You pointed out there's 3 there because I already used 2. I hadn't gotten that far, I was just marking it. He's exactly right, because in this bottom triangle and in the top triangle, they both share that same side. And so they have to be the same. They're exactly the same segment. The distance from L to A is the same as the distance from A to L. So that has to be equal to itself. Okay? And now, why is that true, Paul?
The whole triangle.
Which one of these are? Oh, we didn't say it yet. What is the triangle congruent statement? Someone other than Paul. You've done great, Paul. That back table, I haven't picked on you yet.
Hey!
Kaylee, can you give me give me one triangle? Name one of these 2 triangles for me. ARL? Oh, I'm sorry. I thought you had a little O in there. I thought you said A or L. Okay. Triangle ARL. Now, Kaylee, without help or guidance from anybody around you, can you tell me how to name the other triangle in the same order you chose here? ARL. Let me give you this tip, Kaylee. You went, that's probably right, but let me finish my thought. You went A across the 1 to R, across the 2 to L, and then across the 3. So what letter do we start with that we would then go across the 1 first? L, across the 1 to C, and across the 2 to A. Okay? And I think that's what you said, but I was talking, so I couldn't hear you. Teachers need to learn not to talk while you answer, right? I'm sorry.
True essay.
True dat. Becca, how are you today? Good. Looking at these 4 reasons here, can you tell me which one applies to these 2? Nice. Side, side, side. That's correct. Okay? 8. How do you feel about that? Really? Okay. Let's move on. In this next page, again, it's a little bit time consuming, but I think it's time well spent. It says use CPCTC to list each of the other pairs of congruent parts. Do these pictures look familiar?
Uh-huh.
Yeah.
Yeah, we just did that.
Are they exactly the same as the ones we just did?
Yeah.
Okay. How many facts does it prove to... let me try it again. I said it wrong. How many facts does it take, Nikki? How many facts does it take to prove triangles are congruent? 3. How many facts are there in 2 congruent triangles? 6. So if it took 3 to prove it's congruent, how many are left? 3 more. Okay? Now we have listed up here in the picture BC, segment BC congruent to segment DC, segment AC congruent to segment EC. So those are 2 that are already done. What's the third one you've already listed on this one? Angle BCA congruent to angle DCE. So what I want you to do now, we're going to list the other 3. So there's going to be 3 more over here. Can someone help me with the first one?
Segment A, B, and segment D.
Segment AB.
And segment
okay if you give this a shot?
Yeah.
We've got two sides listed in our picture already, right? And we've listed a third side here. So the last two facts have to be what? Angles or sides? They're going to have to be angles. Good. Because look here, we have 1, 2, and this is 3 for sides, right? And so there's only 3 sides of the triangle, so that means my last two facts have to be angles. So can you name a pair of angles here that are going to be congruent? That's right. Angle A is congruent to angle E. Now, again, remind me, why is this congruent? We just proved in the last page that triangles are congruent, right? So why do we know these are congruent, Aaron? CPCTC. Okay? And then, what's the third one? Anybody? Angle B congruent to angle D. Okay? You know, we're really running out of time and we haven't gotten to what we're really trying to learn today. What are we trying to learn today? Do you know?
Using HL.
How to use HL. That's correct. Nice job. How to use HL. So, I'd like you just quickly to name the other 3 on all of these. 1, 2, 3, 1, 2, 3, 1, 2, and 3. Okay? And I'll remind you, we had this one already.
What was the third one?
We had this one already and this one already. Okay? So we're going to take 4 minutes, no more, and then we're going to quickly write the answers down and move on to what we've got to cover today. Oh, I mean, our 4 minutes is up, so we're going to go through this real quick. I'm not going to call on individuals, okay? If you want to shout out the answer, that's okay. We got to get moving. 20 minutes is not quite enough to do it the way I'd like to do it. So we have, in the first one, we already have angles A and C, angle ABD and angle CBD in this side. So what we don't have are these two sides, right? So that's segment AD congruent to segment CD. And then we don't have these two sides, so what are they called?
Segment AB.
Segment AB congruent to segment
CB.
CB. And then we don't have these two angles. Angle,
D.
can't call it angle D, can I?
Angle BDA is congruent to
Okay,
angle BDC.
angle BDA congruent to angle BDC. Okay, very good. All right, now on this one, we're missing this side and this side. So someone tell me, how do I label those?
Segment F is congruent to segment CE.
F, C is congruent segment
AE.
AE.
I have that back.
We don't have these, so that's segment AC congruent to segment FE.
Then angle F and angle A.
Oh, very good. And they're all alone in this case, aren't they? So it's okay to just use a single letter. Okay? Good. And then the last one.
Angle C angle R.
Okay? Guess I didn't have to use. Now the next ones are harder to label, aren't they? Melody, tell me how to label those two. CAL congruent to angle RLA. Okay, very good. And then then the last one would be these two. And that's angle CLA congruent to angle RAL, right? If you have both of them backwards, that's not wrong. If you have one of these backwards, then it's wrong. But if you went angle ALC and then angle LAR, that's not wrong. It's different than what I said, but it's not wrong. Okay? All right. Any other questions? Okay. The HL theorem looks like this. Says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. Listen, if you use these, let me do this again. If you accidentally leave these words out, it's not right. Okay? I say that because when I typed that, I left them out. And I went back and I was rereading it, as I always do before I give it to you, to make sure I wrote what I thought I wrote. Sometimes I catch my mistakes, sometimes I don't. In this case I did, and I realized, wait a minute. You leave those words out, it's not nearly the same thing. They have to be right triangles. So the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. While they finish writing that, we see this picture. The B is missing, but that's the vertex of this triangle is B. And so we say segment AB is congruent to segment CB. That's why these marks are here. What is this? Segment BD and segment BD are the same, aren't they? So reflexive says that that's okay. It's congruent to itself. And what does this symbol mean? It means actually perpendicular. And then the definition of perpendicular means it's a right angle. And the definition of a right triangle says if it has a right angle, then it's a right triangle, right? So that means these are right triangles. If it's a right triangle, this side is the what? Hypotenuse. And this side is the hypotenuse. And so this is the hypotenuse equal to each other. And they share the same leg. So those triangles are congruent by HL, hypotenuse leg. They have congruent hypotenuse, they have a congruent leg, and they're a right triangle. So by this theorem right here, they're congruent. Okay? Are these triangles congruent by HL? Well, do you agree that this is equal to itself?
Yeah.
Okay? So are they congruent by HL?
Yes.
What's it take to be HL? A hypotenuse. Do we know their hypotenuses are equal? No, we don't know that yet, do we? We have this leg is equal to this leg, and we have this leg is equal to itself. And we have this is perpendicular, which makes it a right triangle, or right angle, I mean. And that makes that a right angle. And then we have a rule that says they are congruent. So they are congruent, but not by HL. They're congruent by side angle side. So the answer is no. By side angle side. Okay? Now, we're going to do this proof real quick because there's a couple steps in here you've not done before. I just said them, but that doesn't mean you caught it. Okay? So we're going to go slow through here. Remember to mark your picture. We've got the perpendicular already. Segment AB and segment BC. Okay? So we want to prove these triangles are congruent, so then we can prove angle A is congruent to angle C. Jacob, put your book away, please. Follow along, because there's some new things here you've not done before. So, what's my second step going to be? And there actually could be one of two things you could put here. Paul?
Segment BD is congruent to segment BD.
That is congruent to itself. Segment BD, congruent segment BD. Other than Paul, can someone tell me why? Reflexive. Very good. Remember, anytime you say something's equal to itself, that's a reflexive property. Okay? Now, how many facts do I have marked in my picture?
3.
I don't. 2, don't I? I have segment AB and segment CB, and I have segment BD and segment BD. That other fact is not one of my 3 direct facts, is it?
No.
It says perpendicular. What does perpendicular mean? Intersect at right angles. So what we're going to say then is that angle BDA and angle BDC are right angles. Remember, when they give us that kind of information in the given, we have to ask why they gave it to me. What does it mean? And so when I asked what it meant, Aaron said perpendicular means they form right angles. Exactly right. So write that down. So what's my reason then? Definition of what? Of perpendicular, because that's what they told me, right? They told me perpendicular. So definition of perpendicular. Okay? Now, remember HL, we said every one of our rules has to have 3 facts, right? HL only has 2 letters, doesn't it? What did I emphasize you had to put in the rule?
3.
What was that third fact I emphasized? You can't leave it out. I underlined it. I said I accidentally left it out. The word right. It's got to be a right triangle, right? So my third fact here is that it has to be a right triangle. Have I said they're right triangles yet? So I have to say that. So I'm going to say triangle BAD. I'm sorry, not to congruent yet. And triangle BCD are right triangles. Anybody know why? Definition of right triangles. And what did we say the definition was? If it has a right angle, then it is a right triangle. We proved it had a right angle, so now we can say it's a right triangle. Now I have how many facts? It's a right triangle, that was one of them. I have the hypotenuse, that's the second one. And I have a leg, that's the third one. So I can say triangle BAD is congruent to triangle BCD because of what? HL, that's correct. Then the last step, angle, forgot what I was looking for. Angle A is congruent to angle C because of CPCTC. Okay? These steps, you're not used to them. Right here. And I know many of you will look at that and say, that's what that symbol means. Yes, it does. But you have to take 2 steps to get there, and you have to put them down. You can't just assume everybody's okay with it. We're not. You have to put them in there. Okay? tomorrow. I want you to have time to write this down. How many statements do I have here? 5 now, right? The 4 we've been working with, and now HL. So on the first one, these are the only way to prove triangles are congruent, and you cannot use these for anything else. So all 5 of these, the only purpose of them is to use them with statements that say triangles are congruent. Okay? That's the only purpose. So the 5 can be used only to prove triangles are congruent. You can't use them for any other statements. If you say angle A is equal to angle C, then you can't use one of these reasons. They don't apply to it. In HL, what's the third fact in HL? Hypotenuse, leg, and? One of the 3 facts is that it must be a right triangle. One of the 3 facts is that it must be a right triangle. When we use CP/CTC, when has it always been? At the end. After what? After you proved what? The triangles are congruent. CP/CTC can only be used after, I forgot to go back and fix this. After one of the triangle congruent statements. I'll have to fix that. This is triangle congruent statements. Okay? I had symbols in there, and when I asked it to switch it to words, it didn't know what to do with them, so it puts D and I. And then I forgot to go back and change it. This can only be used after one of the triangle congruent statements. Okay? All right. Nice job today. I know it was long and involved, and we kept after it, but you did a good job. Tomorrow, we'll work on this in class, and we'll finish this proof. Okay? Or you can try that on your own, and we'll talk about it tomorrow.